stage here at the Engine Performance Expo, the professor of Pro Stock, Mr. Warren Johnson, Mr. Lake Speed Jr. Gentlemen, sit down, get ready, get in, and this is it. Warren's got a book coming out in April. You can get it all over the internet, all the secrets, all the everything. It's going to be in there. I'm super excited to get it, but we've got him right here. Warren Johnson, Lake Speed. Warren, welcome.
Thank you very much.
How are you doing now, Lake? Like this, you know, you always say you're a NASCAR guy. This is our, you know, when it comes to naturally aspirated, this guy's the professor. He's the GOAT, if you will.
Oh, there's no doubt about it. I mean, a couple of years ago, AERA had one of their, what do you call them, seminar days at Total Seal. And Warren came out and gave one of the speeches there. And as I'm watching Warren talk, I was like, I recognize who the competitor in the intellect is. I think I even told you that day, you're like my dad. You're cut from the same cloth as my dad. It's that driven, intense competitor, but that mind's always working, always trying to figure out the way to make that mousetrap a little bit better. And so that's why I was like, we had to have you here. I mean, if we're going to go talk about engines, who else better talk about engines than you're right. I mean, he's the GOAT of the NA engine because, in my opinion, and I've worked with a lot of really great engine builders, the Pro Stock motor is the pinnacle of naturally aspirated engines. What do you think?
Yeah, start there.
They're a little intense, let's put it that way. Try to not leave anything on the table, whether it's porting, any kind of frictional losses, anything to make that needle on the dyno bend just a little bit more. So it gets a little intense.
And, you know, in that search, that's got to be, you know, we see on the racetrack for so many years, of course, Warren's stats, 97 wins, 6 championships, 200 miles per hour. But that happens in the shop and in the engine room. And you maybe go down a road that you think is going to work and it doesn't work. You got to back up, go in a different direction. It's got to be countless hours and just keeping track of all the things that you have done to try to find that horsepower.
Well, that's why I've got these archives upstairs, if you will. And we throw nothing away. We look at it, go up there a year later and think, what the hell was I thinking when I did that? And it's a constant educational program. You're looking at every little finite element, whether it's materials, lubricants, everything. You leave nothing on the table.
And once I'm sure there are things that you tried that didn't work because the technology or the materials weren't there, but as time goes by, oh, that thing I used to maybe try to do, maybe it'll work now.
Oh, absolutely. That's probably the most common question I get asked is, how much faster can these things go? And I said, there's only 2 limiting factors, the human mind and the materials. That's it.
Interesting. Lake?
You know, so when Warren was talking about that every little bitty bit, reminded me of our conversation we had on one of the episodes of the podcast, talking about, you know, Joey Arrington. We were talking about Chad Canals. That's one thing I learned from Chad Canals, who's obviously a great crew chief, is that you don't go a second faster a lap at Daytona with one change.
Nope.
It's probably 10 or 20 changes that give you a tenth or a half a tenth to build to a second. There's this, when you get to the top of that mountain in power, there aren't big chunks. There's no low-hanging fruit left. So you have to be meticulous, like you said, in finding all those little details and just working through them and just, well, that's like you said, when you're done today, you're driving back home because you got more work to do, right?
Absolutely. And it boils down to, it's 100 changes, but only 20 worked.
Right. I remember, I think you said at that AERA event that, you know, you and Glidden, your rivalry was just epic. I mean, everybody, even the NASCAR guys, knew, you know, Glidden. Of course, my dad was a Ford guy, so, you know, he kind of ended up on that Glidden side of the camp.
Everybody's got problems.
See? Continues.
You know, so, but when you were sharing some of those stories about your competition with Bob at the AERA event, that was very revealing. Why don't you share some of those kind of, what did you think about Bob?
Actually, Bob and I, we probably didn't speak 20 words over the 20 plus years that we raced against each other. So not that we hated each other, we hated to lose is what it amounted to, because both of us were kind of unique. We raced for a living. We didn't have somebody piling a bunch of money on us to race. We raced for an actual living. So we didn't have, there was no animosity between us other than the fact that we just didn't want to lose.
Right. No, there's a paycheck on the line.
Pretty simple.
Yeah, exactly. If you're racing for a paycheck, it makes a difference if you win or lose. One of the things that Matt told me about, because I know you did some motors for Matt when he was racing, he said, into the subject we're talking about cylinder head porting specifically, that 1 week you guys dyno tested 5 different cylinder head combinations, and you were every day, at the end of the day, going back and cutting a new set of heads or changing the heads and then redynoing them the next day. Talk a little bit about how impossible that would have been in the past. I mean, Doug Yates was here yesterday talking about his dad and where Robert started, and how that in the old days, or not that long ago, it took him 6 hours to hone a block to get the finish he wanted, and now they can do it in
45 minutes. 45
minutes, and that, what was it, 3 months, he said, to do the Yates D3 cylinder heads in the beginning, and now they can do them in 6 hours. So talk about that arc, that progression over time, because you've seen it better than anybody else.
Well, absolutely. We won our first championship in '92, I think it was, as far as the NHRA side. And in that year, in our shop, we ported 20 plus sets of heads, hand ported them.
Right.
You know, old manual labor.
Yes, sir. Yes, sir.
And we started looking, if we're going to do this for a living, I'll be wore out by next year. And so that's why I invested in my first CNC equipment back in 1992. Now, fast forward to today with the CNC equipment we have today, what we have today, and I've gone through 2 different other CNC machining centers since then. The equipment that we have today, the software is so advanced that we can make changes, literally take the heads off the dyno, make the changes we want in any port, chamber, whatever we're working on, and 2-3 hours later have them back on the dyno. But because the software we have in the Rivalry equipment that we have is so advanced, it far exceeds anything we even dreamt about 20 years ago.
Wow. So, I mean, when Matt told me you were literally dynoing an engine, pulling the heads off, redesigning the port, cutting them and putting them back together by the next morning, that seemed crazy to me. Now you're saying you could do it the same day.
Same day, yeah, absolutely.
Wow. I mean, that's that time. Just recently, yesterday, I did a video yesterday morning with a guy named Jake Raby, who's over in Monroe, Georgia. He's a Porsche guy, and he's been doing some testing recently with the Suma bore, the bore coating technology, and running through ring combinations and things. One of the things that Jake did is we used an air-cooled flat 4 engine, because essentially the cylinders are jugs, which you can remove.
Yeah.
So he can go through a couple of changes in a day, just because it's so easy to take the engine apart. It can be apart in 15 minutes. It's that speed of development that's exponential. Like you said before, I remember my dad's shop. It's a funny story. I walked through there. My dad still does vintage go-karts and stuff. And I walked through the other day, and he's in there in the old cylinder head porting room, porting on a 2-stroke, sleeve. Oh, exactly. Yeah, he's doing all that. And I'm like, I should take a picture of that, because here he is with the grinder over his shoulder, grinding away on this little 2-stroke sleeve. The time that it would take to build an engine in the old days, to test an idea, and then go run it, and they get back, it was so long that your mind can think of so many other variables and changes, but now you can actually test them almost in real time, sounds like.
Yeah, you can make a change, and that's part of the real world of development as far as we're concerned, is you can take and make a change, document that change, make another change, and because we're all prejudiced in our thinking, you can see that, okay, my thinking is not correct because I've made 2 or 3 changes and they've all gone in the same direction, whether it's good or bad. But at least when you document it, you can make really a good progression over a period of time that is way accelerated beyond anything we could do years ago. Like I said, this machine I got now is 7 times faster than the 5-axis I had before, from start of a project to finish.
That's amazing. And the key word you said in there is document.
Yep.
Because we can lie to ourselves.
Oh, absolutely. We're all basically prejudice in our thinking. And
Oh, yes.
that screws things up a lot of times.
Certainly want it to work.
You don't want to make mistakes, but you better learn from your mistakes so you don't do it again.
Well, exactly. I think about some of the things you've done. Of course, on the track, we'll talk about that at some point, but designing the engine that is still in use now. Like, to me, that is a major accomplishment when you watch a field of pro stockers out there, and they've all got that same design. Talk a little bit about that process. Like, we just had a segment about custom parts manufacturing, like thinking of the problem and solving the problem. You solve the problem for pro stock in a way that they still are using your solution.
Well, I was blessed to have that project to start with Oldsmobile back in 1983. But I'm the type of person that looks at the big picture, not just one particular element of it, but take the big picture. Okay, we've got to support the crankshaft better. Cylinder wall's got to be better. We better have a better clamping arrangement so we can seal the thing and not intrude on anything as far as water jackets, spark plugs, ports, whatever. So you have to look at the whole concept of an engine, not just take what's there and work around it. That's just wasted time as far as I'm concerned.
Very interesting. Very interesting. Eventually, there'll be time for a little Q&A. We're going to be over at a machine here real soon, which is going to be kind of cool. I want to spend a little more time on the you and Bob, and more on the racing for a living aspect. Was that a good decision? Race for a living?
Well, you have to understand, I came from an extremely frugal background, so racing for a living looked a lot better than driving a truck in a mine for the rest of your life, which I'm not saying that's bad. We all need iron and steel to build what we want, but that just wasn't for me. So racing looked like something that I could probably do relatively well, and in the long run it proved out, and I'm still having fun, and I can afford to have fun.
You've got a book coming out here in April, and Don the Snake's got a book out now, so a couple of drag racing icons got books out. It's going to be great. What was that process like? Kind of like uploading your life experience, countless stories. I'm sure there's a lot of great stuff. We don't want to spoil any of them, but people are going to be able to buy this. But going through the process of putting your life out there and sorting through these moments, I can think of like a million moments with certain other manufacturers that will be super interested, and I'm going to get the book right away. But the process of going through and having a book written, writing a book about your life.
Actually, I was really fortunate because my wife took every note, every picture along this whole journey.
Wow.
So she was able to provide Kelly Wade, the author, all that information. I mean, there were just volumes and volumes and volumes of records that she was able to dig into, and I think she was kind of overwhelmed with how much information she had at her disposal. So it, as far as I was concerned, there was a few interviews here and there to correct some few processes and so forth, but it was easy for me. My wife and Kelly Wade took care of the whole thing.
Wow. There it is. There it is. Well, we're going to learn a lot more about Warren as that thing comes out, of course. The 200-mile-per-hour run. How much went into preparing for that? It was a milestone that was out there that you were chasing for a while, came close a few times, everybody thinking maybe, the last great milestone in drag racing for cars, certainly.
Well, our whole racing operation has been blessed with that type of performance because we prepared so meticulously. We were the first car to run 180, 190, 200. Kurt ran the first 6-second run, and that was all because of the way we prepared the cars. It was not necessarily all horsepower. You got to get it down to the ground, and you got to have aerodynamics involved. So it was an interesting process for me because there was so many aspects of the operation that you had to address to achieve what you were trying to address.
Lake, I want you to jump in here in a second, but I got one more for the professor, which this whole Engine Performance Expo concept is so we can share information. We want to share information. We want to give other people your information. That's a relatively new concept in what you're doing. Sharing.
That's a no-no in his background.
Exactly. There were people that were trying to find out your information. There had to be some espionage going on back in the day. It's kind of a role reversal a little bit. Now you want to share the information. Back then, you were trying to hide the information. Anybody ever try to sneak around and find your information?
Oh, I've had numerous people with cameras sneaking under trucks, trailers, trying to take pictures of everything we had, overhead shots and whatnot. And there was a couple of instances where I had gone to a school that was with a guy that was taking pictures, and he told me the team he was taking the pictures for. So it was an ongoing deal, but there wasn't a whole lot you could learn from the outside. You know, you look at the outside of a house, you have no idea what's on the inside.
Very interesting. Blake?
Well, it's a great segue, actually, because, you know, backstage we were chatting about something that he had mentioned last week when we were talking, that there isn't a magic recipe that goes across the board. And I think one of the guys yesterday mentioned it, that engines are a system. I think it was John Calley's. Engines are systems. Mm-hmm. You can't take just one component and say, oh, that's the component. It's going to make everything work. But if it does, it was just kind of dumb luck that everything in your system was so wrong that you needed this one piece that would fix it. They all have to have that symbiotic relationship.
Everything is a system from start to finish. They all have to work in unison to produce the results you want.
Exactly.
I mean, you have to look at everything. Like as I said before, you know, materials, oils, what have you.
So let's go somewhere. We're talking about this. This section is supposed to be about cylinder head, manifold porting. Here's something as a chemistry kind of guy that I think about. I'd love to hear your thoughts on. What about the fuel and its role in how you address cylinder head design and flow?
Well, first of all, if you're designing a cylinder head, you have to establish what you're trying to achieve. What's the RPM range? What's the engine size? All of that, what restrictions you have on the intake and so forth. You have to look at all the aspects of what you have to work with. Then you start designing it, and because you're going to obviously have different valve sizes for different bore sizes. So that's the first one. Second is, okay, what's the RPM range we're going to work in? And realistically, because probably the valve train wasn't even designed right to establish that RPM range. So everything has to work together. So you have to look at the complete system. And when you mention fuel, well, you look at a pound of cubic foot of air weighs about 0.08 pounds.
Okay, 0.08.
But that's a compressible medium. You introduce fuel in there, which is non-compressible.
Right.
And if you take it by volume, fuel is about close to 600 times heavier than air.
Yeah, so roughly 7 pounds a gallon, so yeah.
Yeah, okay. So you take that and you're going to put that through the port, something that's got a lot of inertia, and you expect it to flow the same as air. I think we got something going on here that, everybody likes to say that their flow bench is right, but I have yet to see a correctly designed flow bench in all my years of flow bench testing. So they're using a tool that they don't even know anything about. Right. And they're getting a number to spit out that's probably not relative to anything. So it's kind of a bragging rights is about all it amounts to. They got their flow bench test, and I flow this much air and you flow that much air, but my cylinder head is better, and probably neither one of them are worth a damn.
Well, that brings up the question we talked about it this morning with the guys from Melling on oil pumps, pressure versus flow. Mm-hmm. Okay, flow versus velocity. Big difference, right?
Same thing with a cylinder head.
Right. So one of the things about fuel that I find interesting, and some people don't recognize this fact, that we don't burn liquid fuel. Nope. The fuel has to become a vapor. So there's atomization is just taking that bulk liquid fuel and making it into a small droplet. And carburetors and injectors, that's their job. But that job isn't done yet. You got to go from atomization to vaporization. Elaborate.
And still, you got a compressible medium and a non-compressible medium. You're trying to introduce that into a cylinder in a homogeneous fashion so it can burn uniformly. That is really the key to the whole thing.
Yeah, there you go. Now you hit on it. Yeah, it's that homogeneous part, so it's all evenly dispersed, so you don't have two areas that are too lean, too rich, so that you get the flame travel, which we talked about yesterday. Go on. You're the smart one, not me.
I don't know about smart, but look at a fuel engine. They have to have 2 spark plugs in it to get the damn thing lit. Well, that's because it doesn't burn. It goes off in a series of explosions. So gasoline, if you have to use 2 spark plugs to light it, you don't have a properly designed combustion chamber, a la a Hemi. Which a Hemi, as far as a naturally aspirated form, is worst possible design you could possibly have. So I'm not enthralled with any Hemi engines, but yeah, they'll flow a lot of air, but they can't burn a lot of fuel.
The burning of the fuel is what makes the heat that generates the work.
The
And
expansion.
Work, yep, and work is power. Of course, like you said before, in a engine, especially a Pro Stock engine, it's all about minimizing the losses of that power.
Yeah, when you look at the efficiency, I think Formula One has just achieved 50% efficiency as far as power output for amount of fuel they're burning. We're not even close to that right now. We're probably high 30s at best, I would guess.
Oh yeah, I think some of the production engines today say that modern turbocharged DI engines are in that low 30s range. Yeah, but Mercedes did that video. They're at 52% thermal efficiency. Yeah, that's mind-blowing. You know, like you said,
absolutely.
We have a long way to go to get there.
Warren, is that why, talking about flow and the different mediums, why you were such a proponent of fuel injection early on and really trying to push Pro Stock in that direction like 20 years before it actually happened, because you realized that that would be the best way to achieve that efficiency?
Well, I've been working on a development project for a major company that involved fuel injection, and we saw the benefits of that right off. This was about middle 90s, I would guess. But the real advantage to me was longevity, because I've always been a proponent. You can't tune it up if it's blown up. And
write that one
Save
down.
that one.
Yes.
Save that one.
So we saw immediately that would maybe 30-40% increase in engine life. Now we're looking at, on a typical carbureted Pro Stock engine, if you're maximizing any particular component, camshaft, cylinder head, what have you, on a carbureted motor, you could put 35 maximum pulls on it, and you can probably put 8 top rings in it. Not knocking the rings were bad.
No
but
problem.
good for sales.
No offense, yeah.
And maybe pistons, and might, if you knock the pin bores out around, you might be putting connecting rods in there. Now we take them apart at 100 pulls, doing the same procedure, and put the same parts back in with fuel injection. So it's at least 3 or 4 times better as far as engine longevity is concerned, and we're finally achieving more power than we ever did with carburetors, which involved about a year and a half of work redesigning everything to utilize the fuel injection or its advantages.
Very interesting.
I think I can hear Ben Strader cheering all the way from Lake Havasu City, Arizona. Right
Fuel
about
injection.
Now. But she's talking about fuel injection versus carburetors later today, so stay tuned. Don't go away.
Well, I think about that, and there are still some people that talk about the carburetor days, and it was certainly cool and interesting and neat and all, but you had to there was some luck involved. Like, how many sets of carburetors did you have sitting around the shop, and what separated one from the next? Now you can make it what you want it to be.
Well, carburetors, at any one time, we probably had 20 or 30 sets. I never kept track of it, but every one were different in the aspect of metering air and fuel in the ranges that we want. When we ended up with the fuel, the carbureted stuff at the end of it, trying to achieve high-speed power at 10 to 12,000 RPM. The carburetors had gotten so big, they had a very, very narrow operating range, probably in the vicinity of 500 RPM, where they were efficient. Where now with the fuel injection, you can make that thing as efficient as you can over 2,000 RPM, because you can meter the fuel in response to how much air you have available.
Very interesting. Now, we will have an opportunity here in a little Q&A for WJ, but me and Lake are taking that up right now. Like,
well, I got him here, right? I'm thinking, so later this day, Billy Godbold is going to come on, talk about some camshaft stuff. And I know one of the things that came up in even the NASCAR ranks.
Billy's watching right now.
Oh, good. And I'm sure it was done in the Pro Stock days. You can tell me if I'm wrong, that because of a common plenum manifold, and of course you guys with dual carbs, you had not the issue that the NASCAR guys had with a single manifold. The runner links were unequal, so guys got to playing around with changing the cam lobes based on if it was an outer cylinder versus an inner cylinder due to the runner link changes. Made me think, okay, obviously manifold wise, you guys had big split dominators and all that to try to reduce that, right?
In the NASCAR aspect, they had different runner lengths.
Correct.
You can change the size and this, that, and whatnot, but you still got a different length.
Right.
So that makes the tuned length different.
Right.
So because of that, you're going to probably go back and change lobes and center lines
Correct.
to maximize everything.
To try to make each individual cylinder, each individual engine as efficient as it can.
Absolutely. We're back to the efficiency thing. In the Pro Stock stuff, we had equal runner lengths. But because you have a common plenum and you got this buffeting in the plenum, which is common because every firing order has a different phenomena going on in there, you're going to be changing cam lobes and center lines because of that. Not so much as you would in a single four-barrel application like NASCAR, but
that was my curiosity. Is like, okay,
that was approached.
Okay.
Absolutely, yeah.
Did you ever play around with actually changing the port design per cylinder location?
Well, if you can establish what is going on in there, and we did that numerous times with extremely high-speed cameras with plenums that we could illuminate and see what's going on, and what's going on in there, kind of like our election, chaos.
Well, I remember John Kazi a few years ago at AETC had a video. It may be on YouTube, and I remember John is talking tomorrow. Maybe he can tell us where it's at. He did a video where he put his finger in the runner, and he was amazed that they thought for certain my finger was going to get sucked down, and it was getting blown up.
Yes.
Completely
Reversion
opposite.
wave, yep.
Yes.
And that's what causes all this turmoil in the plenum.
Right. So, the kinds of crazy things you don't think about, but they're there because it's counterintuitive. You would think, oh, this thing's sucking and you got all this exhaust going, it's got to be flowing that way, and it was going that way.
And everybody said this stuff was simple.
Exactly. And not at that point, by the way.
That's why you're the professor, though.
He is the professor. And Kazi's out there saying, don't try that at home, kids. Don't try that at home. That's what he said the first thing. Don't try. Everybody's going to want to do it. All right, now's the time for you folks out there to offer up a couple of questions that you might have to the professor of Pro Stock, Warren Johnson, and they're already stacked up.
Oh, good.
As you can imagine. Brian Thompson says, I race NHRA Super Stock with a max intake port CC of 130 cc's. Is there a port velocity compatible valve seat angle requirement relationship? Follow that? I can read it again the second time.
That's a whole bag of worms there.
Okay.
What he's saying is he's set to have a specific volume. That doesn't mean you can't cut the intake port quarter inch off the face of it, have the same volume, and make the port bigger, which changes the velocity. But you have to do that all in concert with what the valve size and whatever restrictions you have on the valve seat configuration. I mean, we're back to this combination thing again.
Interesting. A lot of folks just watching from back in the day. Gentleman out there, Joe, worked with Grumpy and Joe Lapone. I remember watching you guys race against each other at Moroso Motorsports Park back in the day. Is it fair to say, says Greg, is it fair to say that the technology isn't replacing innovation, but rather allowing your innovation to come to life more efficiently, inexpensively, or faster? Like you said, you can try 10 ideas in the time it would try one in the past.
Oh, absolutely. I mean, we've got the ability to make changes now, basically in hours or in minutes, some case, where we didn't have that luxury before. So the innovation has always been there, but the application of that innovation has changed. The speed of it has changed.
Very interesting. Next one, a lot of top level. This is what you were just talking about, but I'm going to give a second bite at the apple. Scott, softball pitcher, says a lot of top engine builders say they no longer rely on a flow bench to port development. Do you? If not, when was the last time you did? So this is right what you were talking about, flow bench.
With the luxury I have with the machine I've got and its software, I've got the ability to make changes without having to go to the flow bench. be perfectly honest, I haven't fired that flow bench up in 5 years.
Wow.
But you couldn't have got to the point without some flow bench development initially, knowing that, okay, in a certain application with this valve inclination and so forth, this will work. If I've got a flat valve train, like an inline valve train, only certain other configurations will work. So you got to have that education beforehand to achieve what you want without the use of a flow bench nowadays. But a flow bench, well, I haven't seen a correctly designed flow bench in all my years anyway, but because they've all got defects. But it's a tool. You just have to learn how to use it, but don't accept the results as being gospel.
All right, next one. Is plenum volume as important with EFI as it is with a carburetor?
It's still important, but not to the magnitude it was with carburetors, because the carburetors had such a narrow operating range.
Okay, next one. With a 4-cylinder engine that has 2 intake ports, cycle 1 and 4 run leaner than cylinders 2 and 3, so all 4 cam lobes cannot be the same. 2 and 3 always run richer, so we need to change the 1 and 4 cylinder cams design, asks Elgin.
Well, I don't know exactly what his application is, other than it's a 4-cylinder engine. But to me, that initially may sound like a manifolding problem to start with. He didn't say if it was fuel injected or carbureted. So there's another avenue that needs to be addressed. But because he's got these 2 end cylinders that are different than the 2 intermediate cylinders, it sounds like a common carbureted engine versus a fuel injected engine with an incorrectly designed manifold.
One of our viewers out there had wondered, with EFI, with a relatively dry intake, what problems with intake flow disturbance do you get when the port injector fires in the fuel?
Relatively dry. What manifold has he been watching?
Yeah.
Well, you've got your injector phasing as part of the injection program. So that enters into it. Injector location enters into it. How the injector is exposed to the intake runner, its location. There's so many variables in there that, first of all, there's no such thing as a dry intake with fuel injection because of the reversion and whatnot, which you were talking about with John trying that test with his finger. So everything enters into what is going on in that port. But I can tell you that a fuel-injected engine does not have an intake port. That a good fuel-injected engine has a significantly different intake port configuration than a carbureted engine.
All right, next one. What years or time frame did you most enjoy pro stock racing?
I enjoyed all of it, otherwise I wouldn't have done it for that long. I mean, it was just a case of that's where I made my living, so you better enjoy it. Otherwise, this is going to turn out to be work.
Well, exactly. And if you're going to do it like you did, as in always on, 100%.
24/7, yeah, that's normal.
You'd have to love it. All right, next one, Jim. Now that the flow bench discussion is out there, what constitutes a properly designed flow bench?
I'll leave that up to your imagination, because the fact that if I tell you exactly what it should look like, you'll only make that change and don't realize what the next progression is. So you better learn how to think first.
Ah, there you go. And that's why everybody is logged on at
I'm going to go back
Do it
quick.
Yes.
On the
perfect timing. We're cycling in more questions.
The question about the dry flow, I wonder if he was actually alluding to a direct injection engine.
Yeah, I didn't even touch on that subject, because a directed injected engine has a completely different port than a port injected engine.
Right, yeah, because there's no fuel upstream.
Absolutely.
Still kind of curious, though. Is there any reversion in that? How much fuel may be transferring back? Because I mean, it's not like the injector's only firing once the valve's closed. I mean, it's firing. Most DI engines from the factory will begin to fire when the piston's at bottom dead center. The intake valve's not closed yet.
Yeah, but at the point of intake valve closure, I doubt that there's that much fuel in the cylinder to be rejected up the right.
I would think you're right.
I would say it's, what little exposure I've had to DI engines, I would say it's probably nil to nothing.
So it's probably yet a whole nother way of manifold port design.
Absolutely.
For dry flow. Because now you don't have those two molecules of different densities
Separating and causing chaos in the bowl.
Are you having fun yet? I mean, this is awesome.
Exactly. Hey, Warren, what kind of racing do you build engines for nowadays? What about that? What are you working on?
We're still doing a lot of development work on the 500 fuel-injected program, simply from the fact I enjoy working on it. We've seen a lot of gains, which I'd never had the luxury of doing while I was racing. But we do some Gymkhana engines and some comp eliminator engines and whatnot. We only take the amount of work that we feel comfortable with that we can do a 100% job on.
Got it. Here's one. Do you measure running engine intake and exhaust resonance rates and establish camshaft design to maximize cylinder filling? Says Brian.
We've got the ability to do in-cylinder pressure testing. We've never really resolved or resorted to that, simply from the fact that we didn't have time. But I'm sure there would be some areas that we could make a few gains in it, but with the way we design our engines to be worked on and maintained, we can make camshaft changes, cylinder head changes in hours. So we can pretty much get along without spending a whole lot of money on in-cylinder pressure data acquisition.
Someone had a question about the location of the injectors, and how do you feel about injectors going under the manifold, pointing upwards as opposed to from the top down?
You put them wherever they work best. I mean, every application is different. You can, well, is he talking about a NHRA manifold where you can't have it above the entry, bottom of the entry runner radius, or what's he talking about? But what I can say is, because every manifold port combination may have some variations in it, everyone has probably an optimal injector location, and it's for sure not the same for every engine.
And it is dictated by the rules of the series of the car that you happen to be in. Like you might build something totally different if the rules were different.
Oh, absolutely, yeah.
Lake, any final thoughts for the professor?
Well, and I think the fuel plays into that too. A good buddy of mine, Ron Shaver, is a sprint car guy. In injector location and injector type, be it fan or spray, is a huge thing just within methanol. So again, the fuel makes a big difference in that as well.
Yeah, he's putting 2.2 times the amount of fuel in that methanol engine as we are in the gas engine. So his location of injector and type of injector is completely different than what we would use in a gas engine.
So every engine has its own recipe.
Simple as that. This has been fantastic. Warren, thank you very much. We're going to have more Warren Johnson coming up in a little bit, so don't go anywhere. Lake, of course, will be back. We're going to continue throughout the day. It's going to be fantastic. But right now, folks at ProMaxx can give us a tech chip, then we'll be back on the other side.
Hi, my name's Jason Collins. I'm from ProMaxx Performance. We are a family-owned company that's been in business for about 8 years. So if you hadn't used our product, we would suggest that you do that. But we'd also like to introduce our brand new line of LS cylinder heads. These heads feature our ultra smooth castings. As you can see, our heads are some of the smoothest in the industry. That allows for our heads to flow as much as our competitors' CNC ported version. We also feature a super huge 750 deck on these heads. These heads will take your nitrous and boosted applications with no problem. We also have billet stands if you want to use your stock OEM style rockers. They also feature titanium or tool steel retainers. Now, these heads have already produced crazy numbers on our in-house dynoing. We had a 350 cubic inch pump gas motor that produced over 607 horsepower at 6,700. It also produced over 500 foot-pounds of torque at 5,000 RPM. Those numbers are on a pump gas motor at only 350 cubic inches. You can put these on everything up to 450 cubic inches. These heads will handle anything that you can throw at it. At $17.95 to the end user, a complete set of LS cylinder heads that will make over 70 horsepower more than your CNC ported OEM heads. That's a price that nobody in the industry wants to hear or can beat. Hi, Jason Collins here with ProMaxx Performance. Mopar owners, you do have options. We have small block Mopar and big block Mopar. We have them in CNC ported and as cast versions in multiple sizes and multiple chamber sizes. Don't just pay for a name. Come to ProMaxx Performance and get the performance you need out of your Mopar for a price that you can afford. Check us out at www.promaxperformance.com. Hi, Jason Collins here with ProMaxx Performance. What I have in front of me here is our Ford lineup here at ProMaxx. We have our Ford Windsor version. We have it in a 175 and a 210 fully CNC ported version. We also have the Ford Cleveland in a 2V and a 4V. Then we have our big block Ford FEs. They're available at 170 runner as cast and a 200 runner CNC ported. If you've got a Ford, whether it be small block or big block, that you need to go fast, give us a call here at ProMaxx Performance and we can give you a price that you can afford and you can go fast. Just check us out at www.promaxperformance.com. Hi, Jason Collins here with ProMaxx Performance. What I have here in front of me is our big block Chevy lineup. We have our rectangle port 317, which has been a rock star for us. It flows over 400 CFM. We also have it in a 340 CNC ported. We have it in a 370 CNC ported and a 390 CNC ported. We have over here our new oval port 290. Those heads will be available here very soon. They flow over 370 CFM. If you're needing heads for your big block Chevrolet and you're needing to make big power and you don't want to spend a lot of money, check us out at ProMaxPerformance.com. You're just a click away from horsepower. Hi, Jason Collins here with ProMaxx Performance. What I have in front of us is our small block Chevy lineup. The small block Chevy is the backbone of the performance industry here in the U.S. We offer it in multiple combustion chamber sizes. In our as-cast version, we have a 183 and a 200cc runner along with a 225. We also have a fully CNC'd 225. These heads feature our ultra smooth castings, 5-angle valve job, hand bowl blending on our as-cast versions. If you've got a small block Chevrolet that you need to perform, give us a call at ProMaxx Performance, where we always offer max quality, max performance at a minimum price.
What a day, what a day, what a day. My brain is swollen. I've learned so much today. They told us, don't start cars. We are not going to listen.